9.2a. Today we're going to talk about the 45, 45, 90 special triangle. If you get nothing from the Pythagorean theorem or trig identities, remember 45, 45, 90, 30, 60, 90. Those are the most important, in my opinion, of what you need to know. So first, number one, classify the type of triangle by its sides and the type. So this triangle right here, notice that two of the sides are 3 and 3. They are equal to each other. So it is an isosceles triangle because it has two congruent sides. Number two, classify the type of triangle by its angles. Notice it has that box in that corner. That tells me it is a right triangle because it has a 90 degree. It has 90 degree in it, or that box. I like to call it the box or the square. Number three, what formula do you use to find the missing side of the triangle? Remember our Pythagorean theorem. We use a squared plus b squared equals c squared. And c squared is our hypotenuse or the longest side. So this here would be our C, and the other two would be A and B. Number four, find the missing side of the triangle. Leave your answer as a simplified radical. Well, remember, these are going to be my A, my B. Doesn't really matter which one is A or B, but it's going to be 3 squared plus 3 squared equals C squared. This gives me 9 plus 9 equals C squared. 9 plus 9 is 18 equals C squared. I square root both sides. C is the square root of 18, but I know in 18 there's a 9 times 2, so this is actually 3 root 2 equals C to simplify it. If I did 18 and I broke it down from the tree, like 9 and 2, this is 3 and 3, this is a pair. This is not a pair, so 3 root 2. Next, my right isosceles. My right isosceles triangle theorem is a 45, 45, 45, meaning both of these angles are 45 degrees. This is 45 and this is 45 degrees. 45, 45 degree angle. In a 45, 45, 90 triangle, the hypotenuse, it is root 2 times as long as each leg. So notice here, this was 3, and then the answer to the hypotenuse was 3 root 2. So if I had anything else, and this was a 45, 45, and this was a 5, 5, this would be 5 root 2. Doesn't matter. If I had, this was a 45, 45, and this was an x, x, this would be x root 2. Everything would be root 2. And it was a hypotenuse equals leg. The hypotenuse would equals leg times root 2, or L times root 2. Don't matter, L times root 2. Let's try this out. So this is a 45. I got x. This is 5. X should then equal 5 root 2. Y, being a leg, y should equal 5. These are simple. N, 45. The m is the hypotenuse. N equals 4 root 2. However, now m equals 4 root 2 times a root 2. A root 2 times a root 2 is the same thing as saying 4 times 2, which is m then equals 8. On to number 3. Ooh, we got an x and a y. Well, I know this is, if I took x, x is this side, this leg here. If I label that, this should be, we'll call this A or C. This C is equals x times root 2. So then x times root 2 must equal 15. That makes sense? So now we want to divide by root 2, divide by root 2. X equals 15 divided by root 2. I don't want a root 2 in my denominator. I don't want a root 2 in my denominator. So that I'm going to multiply by root 2 over root 2, which gives me x equals 15 root 2 over 2. And that would be my answer for x. My y is exactly like x. So I'm just going to leave it just the same. So the 2, once you find one, you can get the other one. Here, my y, that's simple. It should be 14, just like the other side. My x should equal 14 root 2. Number 5, my y should equal, that's a simple one. We got 8 root 2. It should be the same. My x then should equal 8 root 2 times root 2, which is 8 times 2, which is then 16. Here, I don't know what this is, but I'll say u equals 18, and I'll just divide that by root 2. Divided by root 2. So then I need to multiply by root 2 over root 2. U is then 18 root 2 divided by 2. And then V is the same as U. Finally, the last 2 examples, we got 7, y should equal 7, x should then equal 7 root 2. Next one, these are our answers here. X should equal 12 root 2. You want to divide that by root 2, which is then simply 12. That means y should equal simply 12. And that is our answers.